anyone wants more clarification on, just let me know. So yeah, Tune for Dynamic Data, and it was founded by AGI, but now it's really taken on a life of its own. We're still the primary sponsor, but we have many different contributors and people on our forums, and you know, it's really community supported. It's a very active project. So enough talk. I want to jump into first demo here, which is just kind of our basic Cesium viewer demo application. If this starts animating slow, or if I get too far ahead, let me know. But for now, you should see a globe up on your system, and I'm kind of zooming in and out a little. You can also get to this from our website, cesiumjs.org, and play around with it for yourself if you wanted to. One of the first things you might notice, in addition to the 3D globe, is this little timeline and animation toolkit down here. We can actually scrub around back and forth in time, and you see the sun in the background, and this is all accurate. So we do a lot of work to make sure we're precise. So if I happen to be hanging out in outer space here and we're looking, you know, at the Earth from this angle at this time, this is exactly where the sun would be. In addition to a 3D globe, we also have, as I said, we have 2D. This is more of a traditional, you know, either Mercator or other geographic projections. And then we have what we call Columbus view, which is kind of a two-dimensional map, but with height. So it's a flat world. And there's nothing in here right now, but when we have data in later, you'll see that can kind of be a unique view. Right now we're looking at Bing Maps imagery because we have a partnership with Bing Maps, so we include that by default, a demo key. We can also use other maps like OpenStreetMaps, or, you know, if you want to fall back, we have Natural Earth for like local low data browsing. So lots of different options here. I'm also going to turn on, we have highly detailed terrain that we process. So if I zoom to the Grand Canyon here. So once I tilt here, you'll see, you know, we have this high, you know, very high detailed terrain. Depending on where you are in the world, you get some details better than others. So that's actually, AGI has a commercial terrain server that we have hosted publicly to make available for the Cesium community. So anyone is free to use our terrain server. And then obviously we also sell that as a product, you know, since Cesium is open source. But I'm not here to sell you guys on anything. I'm just letting you know how this works. And this isn't Google or Microsoft or anything. This data comes from us.
Yeah, just add in this particular elevation data set that we're looking at here. This is actually sourced from the NED, the National Elevation Data Set. So those height values are actually incorporated into our mesh.
So, and once again, you know, if I look right here, see if I can find it. This is all time dynamic, so we can watch the sunset over the Grand Canyon if we wanted to. So this is, you know, great. This is just our demo. Hopefully that came across. But this is an empty map, so it's not super useful yet. We'll go to some other demos in a little bit. But first, let me just tell you a little bit about more about Cesium and the code base and the community. So as far as JavaScript projects go, this is fairly ambitious. It's a pretty big project. It's 84,000 lines of engine code and 78,000 lines of test code, and that's unminified. And we have quite a few tests and good coverage, and you know, we kind of pride ourselves on this because JavaScript, if many of you have more traditional backgrounds, for example, I was a C++ programmer for a long time and then moved to .NET and Java, and you know, web development is kind of still an emerging world of web apps. We're kind of on the cutting edge here, and it takes a lot to kind of maintain a code base of this size, and it's something we're pretty proud of. As I said, we have a fairly large community. We've been open source and on GitHub since April of 2012. All of our development's out in the open, so if you go to our GitHub site, you can follow development along. You can ask questions on our forum. You can hopefully submit your own pull requests and help us make Cesium better. Just to give you kind of a snapshot, in the last month we've had 11 contributors, 5 of them from AGI. We've had a whole lot of pull requests, a lot of issues. Our forum's growing pretty rapidly. One of the latest benefits of that is because Google Earth has announced the deprecation of their plugin. So by the end of the year, the Google Earth plugin inside browsers is going to be gone. So we have a lot of people that are transitioning from Google Earth over to Cesium. So as I said before, we had an empty globe, and you know, what kind of things do we want to put on it? Terrain and imagery, as we saw, we're working. We don't have yet, but point cloud support. Cities, a lot of buildings and three-dimensional buildings, and people want to browse around. Vector data, polygons, country borders, you know, traditional 3D models. And as I said, one of the things we pride ourselves on is the time dynamic aspect of it. I'm going to jump right into, let me talk a little bit more of the terrain. This is the slide Alex is here for. So the terrain data we were just looking at incorporates the parts of the NED data set, the UEDEM, SRTM. We're actually looking at the newest, what's the newest data set?
SRTM, the 30-meter version 3.
So we're looking to incorporate that, which would give us global 30-meter resolution. And so this is kind of all based around open data for the most part. The SGAIR data is we had purchased, processed, but for the most part we're trying to use as many open standards and open data as possible. The way Cesium works is it's an open source project. One of our goals is to use open data and open standards, and if a standard doesn't exist, we try and make an open standard for it. So for example, in the terrain data sets, in terrain in general, there's no good standard for streaming terrain in a web browser, or streaming terrain at all. The reason is that most people use height maps, but height maps aren't actually a standard. They're just kind of a container format, a way of doing something. In reality, it's an image that doesn't really tell you how to read it. So we developed our own standard called the quantized mesh for streaming data, and we make that available as well. And if anyone's interested in implementing that, we help them. And you can go to our website and read more about that. But it's kind of boring stuff once you get to the standards. I have a slide later that talks about the different standards we support. So I want to jump right into another demo here. And this is more of a traditional mapping application developed by NICTA, the National Institute of Communicating Technology of Australia, which is a government-backed organization. And their job, their goal here was to build a data set of national Australian mapping assets. So for example, I brought up broadband availability here, and you can zoom in, and this will refine and show you the different available broadband areas. You can actually click on the features, and it loads data here on the side of the screen telling you more information about that data. This is all image-based. They have different kinds of maps you can click in, for example, the Australian topographic map. And this was tasked to them to be the national map of Australia. So the goal here is for a data portal for the people who want to interface with the Australian government, or for Australians to go and see the data that's available. Similar to something USGS does on their homepage, I'm sure, and I know you have maps there now. So this is kind of a traditional mapping application. We have, I'm just going to run through a whole bunch of demos just to try and give you a flavor of what Cesium does. This is more of a, this was a more or less non-traditional application that Alex, sitting right next to me, put together the first time he had a chance to use Cesium. This is, many of you may be familiar with D3, that's a very popular graphing library on JavaScript. So this is a D3 demo that shows the health and wealth of nations over a 200-year period. So if you see at the bottom of the screen here, let me actually, well, just full screen it. So if you see at the bottom of the screen here, we actually have starts at 1900 and goes all 1800 and goes all the way to 2009. So this is a 200-year period of health and wellness of nations from this D3 graph over here, but now it's mapped to where the health, the height, and the thickness of a line actually tells you how healthy or wealthy a nation was in that time. So this is just kind of showing how we can provide alternate views in Cesium of, this graph is really cool, but it doesn't give you a lot of kind of geospatial notion of what you're looking at. Whereas here you can actually click on, see a country and click on it, and it'll tell you what you're looking at. And one more quick demo before I go into, show you some little code snippets and some more developer-friendly things. This is actually a very non-traditional app, again, built by NICTA for sporting. So if you look at this here, this is actually an 8-hour hang gliding ride. I didn't realize people did hang gliding for 8 hours at a time. But so what this site lets you do is actually upload your GPS tracks, kind of like, Map My Run and all of these other, Facebook social aspects out there. But it turns it into some really cool visualization in Cesium. So in this case, we're looking at, this hang gliding run. It's got all kinds of different statistics for the people. You have, the line. You can jump ahead in time, and it'll follow around pretty cool. This actually has, all kinds of different modes you can turn on for, themes, night vision, or, all these kind of just cool overlays. And this is not a traditional GIS application at all, but just trying to show you how versatile Cesium can be and what it can show. And for those of you that kind of follow along tech, this actually also has 3D support for 3D headsets, Oculus Rift being the more popular one. So if you really wanted to get the full make yourself sick hang gliding experience, you can. Unfortunately, we haven't had a headset like that here yet, but it's pretty cool. So those are some of the kind of high-level examples. I'm going to jump right in now to something a little more code specific. So if you download Cesium, whoops, one second. If you download Cesium, one of the things we include with it is a kind of a learning tool that we call Sandcastle. And the goal of Sandcastle is to kind of let you do live coding. So on the left side of the screen here, we have a bunch of, your JavaScript code, and you hit the run button, and on the right side of the screen, it actually is the JavaScript. So, for example, if we wanted to show Cesium's geometries, we can show how would I make boxes on the globe? So, example here, we have 3 boxes, blue, red, and outlined, and the code over here shows you here's a blue box, here's a red box, and here's an outline box. Now, obviously, looking at code during a presentation isn't a lot of fun, but I just wanted to give you guys a sense of, some of the capabilities here. So we have a whole library of different shapes. So we have boxes, we have circles and ellipses, we have like air corridors, cylinders, cones. I know some of you were interested in polygons, for example, so I'll spend a minute here. So we have several different ways you can have, a polygon just on the Earth. You can have a polygon with holes in it. You can have extruded polygons, extruded shapes. You can have awkwardly extruded shapes where, the tops and bottoms don't necessarily match. In this case, editing these things become pretty easy. So if you wanted to put a polygon at altitude, for example, all you have to do is add a height. And you can actually show a few of them this way. They're still all red, but as you can see, now we have polygons at different heights. So one of the strengths of Cesium is that we try and separate out the actual low-level graphics rendering, the complicatedness of what you're doing, and the data. So you give us your data, and then we'll show it on the screen. Just as simple as, here we're showing everything as colors, but if these needed to be images, you could just replace this line here with a link to an image, and then the image will show up instead. So that's kind of like some of the other things we have. So here, once again, show you some 3D models also, if you're doing kind of, very up close, if you wanted to have, hey, here's all the telephone poles, or here's some aircraft, or here's the different characters we have, everything from skin characters and models. And this is all just an external model file. So in this case, we're helping build one of the new standards for model formats on the internet called GLTF, which is another standard being developed by the Kronos group. And then finally, I want to talk about something you probably are more interested in, and that's kind of working with existing data standards and maybe existing data sets. So Cesium has a fairly robust system for loading standard data sources, and also a plug-in point for taking data you might already have in some format and ingesting it into Cesium. In this case, this is a GeoJSON or a TopoJSON file, which is very similar, kind of like a JSON-based shape file, hopefully many of you may be familiar with. And here, GeoJSON doesn't really have any built-in styling information. So here we have, the countries, the state of the states. And you can click on each one. It kind of gives you some information. Here's when it became a state. Here's the population. And this is fine, but it's not very appealing to look at. So we make it easy to kind of style that, to say, okay, well, now make the outlines hot pink and the inside pink, and now you get something a little better. Where the power comes in, though, is our ability to kind of add custom styling to this external data. So, for example, in this visualization here, we have, here's the states, and now we've randomly colored them just to make them look more appealing, but then we've also extruded them based on their population. So in this case, we have, we're taking the population from one of the censuses, we're dividing it by 50 just to make it more, so they're not like all the way out, too far into the earth. And now you can actually get a good view of what this looks like, kind of population of states from one to the other. So this is just a sample of saying how you can apply some of the metadata available to these, vector data and kind of make them pop a little bit more. We also, to go back to that Columbus view I was talking about before, so if you wanted to get, say, Alaska in there and Hawaii, although Hawaii's probably cut off partially on the other side here, but this view kind of lets you see everything all at once without having worried about the curvature of the Earth, but there's still height here. And then finally, one of the other things we wanted to do with Cesium is that we found that there are lots of standards out there. For example, there's GeoJSON data, TopoJSON data, Kml is one. We're actually actively working on Kml support. But as I said, a lot of these standards don't support time dynamic data. So, for example, here's just kind of a simple bread and butter type of visualization we at AGI might do, to where we have some satellites orbiting the Earth, and these satellites orbit the Earth, and then we want to know when they can see a point on the ground. So you see, as they're moving and as they have visual contact with each other, what we call line of sight, a kind of line pops up. Here's the ISS, here's GOI, and as they're orbiting the Earth, we can actually scrub around forward and backward in time. And then on top of that, when they do have line of sight, we have this line come out of nowhere to say, oh yeah, you can see that on the ground right now. And we can also track these things, so I can double-click to zoom to it and, move around, zoom around that center location, which is something most other maps don't kind of support. But one of the important things that this is no code. All of this is actually stored in a format we call CZML. So the goal of CZML, it's short for Cesium language. It's not a markup language. People just thought it was an amusing name because it was Cesium. So Cesium language, and the goal is to kind of make it easy to define a full scene in Cesium and provide data-driven visualization with time without having to code anything, to make it easy for people to use, just like people use Kml all the time now. We developed that alongside the Cesium project, and there's a link here to our guide, but if you just go to cesiumjs.org, that has a lot of information there as well. I just want to, again, jump right back into some of the other demos we have. So, for example, if you wanted to do some sort of ground-based visualization of kind of overlaying data, heat maps, and other things on the Earth. So here what we have is we actually have the full GPS constellation, and, these are kind of cool in itself. They're orbiting the Earth. We can zoom in on them. We can get a little bit of a track. If we zoom in closely, you'll see we actually have the 3D model of the actual GPS satellites, and it's oriented properly along its direction of travel. And so, okay, that's cool. But on the ground here, what you'll actually see is the quality of your GPS. So this is over, we use some of our tools to perform analysis, and as the colors change here, green is, oh, you have a really strong GPS signal, yellow is you have, an okay signal, and red is you have a pretty poor signal. So if you're in the middle of the Atlantic over here, you might have some problems. So this just, and then once again, this just animates over time. So it's just kind of showing data in ways people are not used to necessarily seeing them. And we can do this again, in 2D and 3D, and we can kind of show that data over the map. But the important thing is, once this file was created, there was no special custom code. You could create files like this by hand, or you can, write scripts to generate them. You don't have to worry about writing a custom application just for that, although a lot of times people do. And then one last demo, before I'll go back to some slides, is I want to show you some, this is traffic, low-level visualization, so in Oshawa, Ontario. This is kind of street traffic, so each of these blue dots is a car, and you can actually see them at the stoplights. They pause and they start up. I'm going to speed this up a little bit. And every one of these things is being actually accounted for individually in Cesium and in the file, so it makes it very easy to kind of, see, okay, well, I want to have some huge data set that happens over time, and now I want to animate it, but then I want to be able to interrogate it while I'm looking at it. And, travel back and forth and pause and rewind and all those types of things. So that's kind of at a high level, I'll skip that. That's kind of a high level of what some of the things you can do with Cesium. It's really a very versatile tool. We expose multiple layers of APIs. So at the very top of the layer, you have, the entities and the data sources I was just showing you, but also things like imagery and imagery layers and polygons and shapes. And then as you go lower down, you get in kind of like the graphics mode. So if you're somebody who's familiar with graphics development, you can actually really manipulate Cesium and make it do all kinds of things, complicated, both 3D visualization, but also, enhanced 2D visualization to where if you wanted to shade the terrain a certain way or, shade your polygons and geometries instead of just having a solid color, you wanted it based on temperature or something. All those things are possible once you get into there. So as I said, we try to use as many existing standards as possible. So here are some of the standards that we currently support. Our own CZML, GeoJSON, TopoJSON. Simple style, which for those of you who may not be familiar with, is a way to style JSON data, GeoJSON data that Mapbox came up with that we implemented. And quantized mesh is that terrain format I was talking about. And then GLTF is the 3D model format. On top of that, we have lots of streaming imagery standards. So if you have any kind of WMS server, tile map servers, WMTS, OpenStreetMap, we can actually support all of these. So you may have in-house existing servers stood up, and it should be trivial for you to point Cesium to it and visualize your data. For terrain, we have multiple terrain servers. They're not listed here. Our own terrain server. We also support a company named VTMock. They have their VR the World terrain server. And we've done some prototypes integrating with ArcGIS server terrain, but some of those formats aren't very web-friendly. You can do it, it just takes a little more work, and not something we have out of the box at this time. And then I feel like I went a little faster than I should, but hopefully you guys will have some good questions. I want to give you some lay of the land of where we're going with Cesium in 2015. And the first is actually next week we have a fairly big release, maybe our largest release since 1.0, to where we kind of added a whole new high-level entity API. Some of the things I was showing you today are going to be part of this release to make it really easy to deal with polygons and shapes and geometry and kind of start writing really robust applications. And that kind of API is going to map better to maybe more traditional maps like Google Earth, where you're used to dealing with place marks and kind of these higher-level objects. March 2nd, actually, we're going to be releasing Kml Support for our first time. I don't know if you deal with Kml, but it's very popular. A lot of our users obviously have wanted us to implement it, and we're working on that. And then for those of you who may go to FOSS4G, we're actually going to be there. Several of us will be there in March, and I'm giving a talk that'll be build on it. This talk is a very high-level intro talk, but talk more about temporal visualization and how you can use Cesium, and we'll show some of the newer things we're doing like Kml Support. So if you come out to FOSS4G and you want to meet with us in person, that'd be great, and I'd be happy to talk with any of you. Patrick Kozu is one of the co-founders, along with me, will be there as well, and some CI people will be out there as well. And then some of the bigger things we're doing later this year is streaming 3D buildings, something that Google and Bing Maps and has now using some of the, aerial photography and reducing the 3D buildings. We're looking into ways to expose that through Cesium. We are looking for data partners and trying to find open data sets. We've done some initial prototyping with OpenStreetMaps, but unfortunately a lot of height data is not available in those cases. And we're also looking at better streaming for vector tiles, which is going to be needed both for KML, for traditional region support, but also just to bring in highly detailed country borders and city borders and all kinds of data that might be traditional in a streaming format that's too big to pull down all at once. So, as I said, you can go to the web, go to cesiumjs.org. You can, feel free to email me directly, mamato@agi.com, or Danielle can share information as well as Patrick's information. And, if you're social, you can always follow me on Twitter, too. I tend not to tweet too much, but we do stay up to date on the various Cesium, news, and we have our own Cesium Twitter account as well.